Lesson 10.6, Trigonometric Ratios. Your objective is to find and use trigonometric ratios. Vocabulary. Trigonometric ratios are the ratios of the sides of a right triangle. We use the acronym SOHCAHTOA. Sine. In a right triangle such as triangle ABC with right angle C, the sine of angle A is equal to the length of the side opposite angle A over the length of the hypotenuse. Cosine. In a right triangle such as triangle ABC with right angle C, the cosine of angle A is equal to the length of the side adjacent to angle A over the length of the hypotenuse. Tangent. In a right triangle such as triangle ABC with right angle C, the tangent of angle A is equal to the length of the side opposite angle A over the length of the side adjacent to angle A. Angle of elevation. An angle from the horizontal line up to a line of sight. It is used to measure heights indirectly. Angle of depression. An angle from the horizontal down to a line of sight. It is used to measure heights indirectly. Trigonometric ratios. So here we have a right triangle. Here's our right angle, and here is our angle theta. When we're talking about the adjacent and opposite sides, if we're talking about this angle down here, the side that's adjacent to it is the side that creates that angle with the hypotenuse. The side that's opposite is the side that's across from it in the triangle. If we were talking about this angle up here, then the side adjacent would be this side and the side opposite would be this side. So we use the acronym SOHCAHTOA to help us remember the ratios. So, SOH is short for sine is equal to the opposite over hypotenuse, O over H. CAH, C-A-H, is short for cosine, which is equal to the adjacent over the hypotenuse, or A over H. TOA is short for tangent, equal to the opposite over the adjacent, or O over A. You can use the sine, cosine, and tangent ratios to find the measurements of sides and angles of right triangles. What are sine of A, cosine of A, and tangent of A for the triangle shown? So here we have triangle ABC. Angle B is the right angle. So the hypotenuse is 5 and the legs are 3 and 4 meters long. So first we need to find the sine of angle A. That's this angle up here. So we have to identify the opposite leg, the length of the opposite. So the opposite leg is this one. And the length of that is 4 over the hypotenuse, which is 5. So the sine of angle A is 4 over 5. Cosine of A is equal to the length of the adjacent leg, which is this one right here, and that measures 3, over the length of the hypotenuse, which is 5. So the cosine of angle A is equal to 3 over 5. The tangent of A is equal to the length of the opposite leg, which is 4 meters long, over the length of the adjacent leg, which is 3 meters long. So the tangent of A is equal to 4 over 3. You can use trigonometry to find missing lengths in a right triangle when you know the length of one side and the measure of an acute angle. To the nearest tenth, what is the value of x in the triangle shown? So here we're given the length of the hypotenuse as 15, and we're given that the angle measure is 53 degrees. We're looking for the length of x. So first we need to write an equation. So we know that the angle measure is 53, so we can substitute that for our angle name. So we have the sine of 53 is equal to the opposite leg, the length of that, which is x, over the length of the hypotenuse. So we can rewrite this as sine of 53 equals x over 15. In order to solve for x, we need to multiply both sides by 15. So we have x equal to 15 times the sine of 53. We use a calculator to figure out the sine of 53 and then multiply it by 15 to get approximately 11.979, etc. We can round this to the nearest tenth, which gives us 12. If you know the lengths of two sides of a right triangle, you can find a trigonometric ratio for each acute angle of the triangle. If you know a trigonometric ratio for an angle, you can use the inverse of the trigonometric ratio to find the measure of the angle. Use the sine inverse, cosine inverse, or tangent inverse on your calculator. What is the measure of each angle in the triangle below? So we have triangle ABC. B is our right angle. We're given the length of the hypotenuse and one of the legs. Since we know the length of the side adjacent to angle A and the length of the hypotenuse, we use the cosine ratio. So we're looking for all the measures of the angles, and since we're looking for A first, we know the side adjacent and the hypotenuse, so we're going to use cosine of angle A is equal to adjacent 12 over hypotenuse 24. We can simplify 12 over 24 to 0.5. And in order to figure out the measure of angle A, we use the inverse of cosine. So the inverse cosine of 0.5 will give us the measure of angle A. And we use a calculator for this, and we get 60 degrees. Now that we know angle A is 60 degrees, we also know that angle B is our right angle. We can figure out the third angle by using a special property of any triangle, is that all three angles of a triangle have to add up to 180 degrees. So we do 180 minus 90 minus 60 to figure out that angle C is 30 degrees. Using an angle of elevation or depression. You can use trigonometric ratios to measure some distances indirectly. To measure such distances, it is often convenient to use an angle of elevation or an angle of depression. An angle of elevation is an angle from the horizontal up to a line of sight. So that would be, for example, if I'm standing here by the tree and I'm looking up at the hot air balloon, that would be my angle of elevation. An angle of depression is an angle from the horizontal down to a line of sight. So that would be if I were in the hot air balloon looking down at the tree. So that would be my angle of depression. When you solve real-world problems using trigonometric ratios, you often need to round your answers. The problem may tell you how to round. Otherwise, round your answers to the precision of the measurements used in the problem. For instance, if the problem has measurements to the nearest 10 feet, round your answers to the nearest 10 feet.